Hello.
Hello, Euro. Good afternoon, Euro. Is it everything is okay on your side?
Yeah.
Did you take your lunch without me?
Yeah.
Okay. You never invite me to lunch, huh? Okay. I'm sad. Euro.
Um, yeah.
Uh, so your exam is coming soon, am I right?
Yeah.
Mm. Are you afraid?
Um, I don't know. I don't know.
Okay. Well, afraid does not really help, so it's okay. Just keep cool. If I remember my past exams when I was a bit younger than you. So it doesn't really help. It doesn't really matter if I was afraid or if I wasn't. Of course, little bit tension help your body to be ready and to maybe your heart to beat a bit faster and maybe you're pushing more blood to the brain. So that's slightly better. Um, Before you show me your homework, let me try to share with you here something. So I think you can see my screen, right?
Yeah.
Okay. So let me show you a few commands that we would like to actually try to implement. So I will put two, and then previously we did not implement that, but I think maybe it's time to do that because we have moved diagonally so far, but only one step, if you can remember in the previous class, right? But
Yeah.
then we needed to force the direction to actually be downright. But we got no way to do that from the commands. So if I would actually try to implement that from the command, so I would say RT45, just for example. So if I press go like that, you will see that I was able to actually instead of my direction to the right, I become downright. So only then I'm allowed to move diagonally. So what if actually I don't want to move diagonally? I want to know, I mean, this is something that we would like to know to get to the goal faster. So I would like to ask him how many steps you are able to move diagonally before you hit an obstacle. So I mean, let us face it. If you keep moving straight, if you keep moving straight, there will be a lot of obstacles. And the fastest way to move from this point to this point is to move on the diagonal. I mean, this is from mathematics, right? So if you
Yeah.
move here and then you need to go down, definitely, first, you will face a lot of obstacles. Second, it is more steps that you need to take. So the best way is if we would like to think of the minimum amount of steps that we need to move to take from here to reach the goal, I would say we need to implement something that can help us diagonally. So I don't want to actually um, just go step by step. That is a waste of time. So let us think of a way that if we ask the program, so we say DG max. This is not the best way to do it, but let us watch out. So if I say go, Digimax will actually print something for me. It will do what? It will tell me the maximum downright steps before you hit an obstacle is 7. It does not move the arrow yet. It's just telling me if I want to move diagonally, I am able to do that for 7 steps. So, okay, so I ask it first before I issue the command so that I don't face an error. So let us try, if I say DG 8, based on the information, I will put 7 instead of 8 because here the steps is telling me 7 because I asked it before I move. So now I will start to say, go have a look now. Where is my arrow? So my arrow moved from here to here, right? So
Yeah.
why it stopped here? Because the obstacle here. So okay, now I become very close. If you look here, I'm become very close to actually this goal. So what if I use the command that I used before? So I used before, we implemented fdmax. So fdmax will allow me to move forward. But there is an issue here. The issue is that actually the code does not, or the program does not really produce an error. And at the same time, it does not move the arrow. You know why?
Yeah.
Why?
Because you can't move forward.
Yes, exactly. So I have to do what? So I have to move the arrow left, right, 45 degree. So I have to adjust. I have to turn the arrow to, so I have to move it like this, 45 degree only. Because, I mean, if you look at this, and at the moment, I am here. And when I'm down right here, I am 45 degree from the right. And if I have my arrow to the right, it means that I'm able to move forward. So let us try to do that by just writing left. So what if I, instead of writing left, so I said right 45, and I say go. So look at the arrow. So the arrow moved down. So you asked it to move another 45 degree to the right, which means that it will become here. But we don't want that. We want left 90 degrees, because I'm here, and to make it right, I need to move it 90 degrees. So let us try to do that. So I would say 90 degree. Maybe, yeah. Let me see. If I say go, let me see also, it's testing for the code. Does it move? It doesn't move. This means that there possibly an error, or possibly I write it wrong. So let me see. LR 90 degree. LR 90 degree. Let me check the code. If I say here LR 90 degree, LT, sorry, it's LT, not LR. So, oh, if I want to move 90 degree, I just write LT. That's what I do. I did it. So maybe I need to modify that and improve that. Let me see here. If I say LT only, will it really actually, okay, yeah. So you see here, so from here, if I were to move 90 degree, so I just write LT. Of course, this need improvement. And that's what we are trying to do. I mean, no code is 100% perfect. So now I would like to write, I mean, are you following up? Am I moving so fast?
No.
Okay, so if I said fdmax, you did implement it in the last class. So fdmax are actually moved all the steps until it finds an obstacle, and it stopped here. So one of the possible ways also is to say diagonal again, because I mean, if we focus on making diagonal moves, then we are going to actually reduce the amount of steps that we want to take. So let us try to move here diagonal. So I would say I have to write. So should I move right or left?
Left.
So I say LT 45. Is that correct?
No.
So, okay. I mean,
just write LT 9. Just write LT and then just do fdmax and then you reach. Because
okay.
it's already, if you put LT, it automatically means 90. So you don't need
Okay.
to write thing.
Okay. What about now? So LT, if you LT, you are moving this way. I mean, left turn, it means that you are moving
Oh,
against.
wait, a right turn.
Yes, exactly. So we need to move to the right. So if I say RT and I say go, that will move 90 degrees. I reverse the previous command, LT. But never mind. So I would say RT 45 to be able to just I mean, now I moved it here. Okay. And okay, again, diagonal is more, okay. Let us think about it. If you tell me that I would like to go down and then move like that, FD max, so that how many steps is that? That is more steps, because if you look at the triangle like that, it means that if I move on the diagonal, it is lesser steps. If I move down first and then move to the max, definitely there'll be at least one step extra that I need to take. So let us have a look at the diagonal first. And if we want to move diagonally, so I will still say DG max, and I say go. So it will tell me I'm able only to move one step. Okay, totally fine. DG 1, and I will say go. So it already moved. Now I will try to do, can I do FD max here, or I need to turn it first?
Turn.
Turn.
You
Okay,
just turn first.
what should I write?
Left turn 45.
Okay,
Oh.
go.
FD max.
FD max, and then I would say go. So okay, so it means that I was able to reach my goal, right?
Yeah.
And okay, so although I already take less amount of commands to be able to reach there, but he counted 30 commands. Why? Do you know why?
Because there's a lot of errors.
Not only this, but there is certain times that we actually moved. So FD max, if you look at it, it does move many steps, right? But I mean, it's only one command, but the steps is more. So I don't think that we run 30 commands. So I would say that there is possibly an error or a bug here. So we need to confirm that you are, I mean, we need to look at this code so that you are not surprised at the exam that he will tell you, find the error on this. So this we will never reach if we never try to reach the goal here. So I would say that this need revising, because I don't believe that I wrote 30 commands. That need double checking just to confirm that we are really writing proper comments. One of the ways is to insert every command that we do in actually an array, and then we check the length of the array. So that is one of the ways to check if we really issue 30 commands. Okay, so at the end, okay, what you didn't implement here is the diagonal move with many steps. So you implemented diagonal move with one step only, but you did not implement it with maybe 4 steps, okay, or 7 steps. You need to do that. And that's not so difficult. That is slightly easier. But the trick that we have to do together is to change, I would say, to change some of the codes here so that you are able to turn 45 degrees. Okay, so that is also one of the things. Definitely you need to change in different places. It's not only about issuing the command left turn and right turn 45 or things like that. No, there is many. You need to modify really the turn function. You need to modify that totally. Not totally, but just a little modification here and there. And you need to implement DG max, which is, I mean, that could be checked, or maybe you say DG check CHK. That is also a possible command. This check will tell you how many commands you are able to move diagonally before you hit an obstacle. So are we able to do that? Do you think it's possible, or it's too much work?
Yeah, what's DG again?
DG is diagonal.
Oh, okay.
Okay. So we can call it any names. I mean, we are trying to simulate what is coming in the exam, right? So we are free to name it whatever. You say you can say DA or DI or DG. It's up to you. It's totally up to you. But that's what I implemented. So yeah, now before we start doing the first thing, which is to do the turning and be able to actually move 45 degrees, I would say that let me check your homework. How was it?
Oh, this work.
It didn't work. Why? Why it didn't work? Okay. Uh, Jan, share it with me.
I was supposed to do a backward.
Yes, you're supposed to do a backward. It doesn't work.
Yeah.
Okay. Okay. Just share it and then we see.
So I added a backward because for backward you can go like anywhere. Because you said I think it's an undo. Wait, was it backward or undo?
No, undo was slightly different. I mean, your homework was to do the backward. So backward,
Backward is
mhm.
like back one move.
Yes, exactly.
Yeah, so that it can be any direction. So
No,
then
it cannot be any direction. It can be, if you are, your arrow is to the right, so you need to move one step to the back, but it is in the same axis.
yeah.
Okay.
So it depends on what direction the user was in. So then if the user was in up, the direction is up, then and it is and yeah, it is forward.
May I know why you need to put a direction backward? You have up. Okay. Mm, I mean, that's a bit weird to me. Um, so the backward, okay, the backward PK is a command. Okay. So when you receive a backward command, then you need to implement a function that I would say that try to subtract. Give me a second. That try to subtract from where you are. So if you are to the right, then it will check the number of column at the moment and subtract it by one. And from instead of you are being here, you will actually be in this place. So you moved backward just one step. So how are we going to implement that? I mean, I find that when you write okay, let me see first what is the function that you're using here. Go up. I'd like to see the function, please. Yeah. So you check forward, you changing in the check forward. I don't think this is correct. I think it's better to implement. I mean, there is no
A new one.
direction.
Should I
Wait,
name it like check? Should I name it like check backward?
yes, or even a process backward. So you are not checking backward. You are actually, you are, yeah, you're not checking backward. You are actually moving backward. So you can say process, you have a process forward. So we can say process backward. Okay. And direction never become backward. So the direction is always up, right, down, left, and so on. Yes, not bad. Okay. Okay. I would say, can you try to call your function now? I mean, you did not call it yet. I mean, you did define it, but it's not called. So show me where in the command you are actually processing. Yeah, where in the command? Go down, process command. Yeah, process input. So where is, so where is here? Backward. Ah, okay. What about if you write process backward? I mean, yeah, process backward. Okay. Yeah, just try to call it. I mean, I'm not sure what you're trying to do here, but okay, let's see. Okay, just move one step only. I mean, you didn't move yet. You couldn't execute that, actually. Okay. No, it doesn't. Could not execute it. Where is this code, please? Can you tell me where is this code?
It still wouldn't work. Should I have changed the direction index?
Direction, you should not change the direction. There is no need to change the direction. What I would say that the one who really implements the move, if you ever, when you change pointer row and pointer column, actually, this is a real move. So you're really moving your arrow when you change this and this. So when you wrote, can you show me again the code that you wrote for process backward? Slowly, process backward. Okay. So process backward, you said if the direction is up, let's look at the right first, because that is the one that we're having. So you are saying that, you did not implement that here. Okay, I got it. So if you are right, you're checking, you're returning if this is true or, okay, I got that. I wouldn't say that your code is wrong, but I would say, in this case, since you are only checking and returning true and false, I would say maybe say check instead of process backward, say check backward, and yeah, and okay, now I got it. So here you are only checking, and you only return true and false. Where is the function that you made just now? You was trying to do? which is yeah, move backward. So you need to make a copy from the move forward and try to reverse it here.
Already.
You already done it. Okay. So you don't need to write this. This is not needed because backward is a command and it's not a direction. The direction is up, right, down, left, down, right. Okay, that's good. And you say direction is up. If the direction is up, you let's focus on the right to make it sure because yeah, that is actually correct. I think your only issue, actually this is correct. So your only issue that you did not call this. Where, show me where you call this. Go down, yeah, you see. So you need to check that to check backward. And yeah, move backward. And typically this is a function, you need brackets, please. Yeah, okay. Okay.
I don't know what's wrong.
No problem. Just no problem. Don't panic. So we need to make sure. I mean, now we are blind. We do not know why there is an error. So this, it seems that it returns false. And we do not know why it's returning false. So we need to understand that. Most probably when he say, so it means that most probably this is returning false. That's why we are seeing this error. So, but I see that here is free. So I would say that most probably our check should be here. So we should check backward. So go to this function and let us go step by step in it so that we know that we are really checking correct. So, okay, check backward. If the direction is up, so I would say the first thing that we do, oh, where is your semicolon here? Okay, can you try to run again, please?
My God, this was the problem.
I'm not sure, but I mean, that seems weird to me. So let us confirm that it is not an issue. Okay. Oh, still doesn't. Never mind. Okay, so we go step by step. Can you please? The problem is in check backwards. So can you add? Can you press enter here? Here, and I would like you to add a print statement. Print direction. I would like to see this direction. What is it? Okay, that's the first thing. And you say here, give me a second, please. You are referring to this not equal obstacle. So it should return true. So I would say, come here and press enter. Come here, yeah, press enter. And I would like you to put a print statement and put inside it this. Put a bracket, please. Okay, so we try to run. If we see that, yeah, minus, you cannot write, yeah, just careful from this. Okay, interesting. Mm-hmm. Wow. It means, I mean, we never printed that totally no printing for this, no direction, no printing for this. It means to me that this PK is not accepted as a command. It does not even call this. Can you go down to the process input? It means that, so yeah, I would like, yeah, go down, please. And let me check, where is your bag? PK. PK is not accepted. Can you come here and put a print statement and put inside it, go backward in a double quotation? I would like to see if you're really calling this correct. That's a bit surprising. Okay. Wow. You do not even, I mean, do you notice here? You don't even print that. Your PK command is not even running. You don't even call the PK. That's quite weird. Let me try to digest what could be possibly wrong in this code. You just copied exactly like that. It should come here and print.
Yeah.
Are you able to, can you try other commands, please? I would like you to try the RT and even the LT. Try the LT, please. Okay, so it's working. What about the DR, please? Write the DR. We tried this command. Okay, so it's working.
Yeah, exactly. You don't know what's wrong with it. Like computers, some problem.
Why is that not executing? What is the issue here? Okay, first of all,
Say.
mm,
Maybe it cannot. Maybe it can't carry out functions.
I mean, so I mean, we are able to do it with downright and with we are, I mean, here you're already putting. So why it doesn't? It doesn't even print here. It means that this if statement is not executed. What about if you write SPC? So can you execute here SPC and write go? So it doesn't show anything.
Because SPC has nothing.
Yes, I understood, but okay. Why on the earth this is not working? Quite weird. Can you search for PK? Can you put here PK? Okay. Oh, it's only one. Okay, that's a good sign. Go backward. Okay. Just remove this part, please. Okay.
Leave it hanging. There's an if statement.
If, and then you move backward. Okay, but why? Okay, and do me a favor, take this code and put it here. Whole code, yeah. Just copy it or move it all. This is a weird problem. No, you need to fix the indentation and make sure that you okay. Could not execute line 1 PK. Could not execute line 1 PK. Wait. Something is actually wrong here. This is still 1, 1, but you are not in 1, 1. That's quite weird. That is quite weird. You are checking.
Did I delete this part?
It doesn't. Yes, of course, you definitely need to delete it. Yes. Why are we still at 1, 1, even though we already moved here? Go up, please. I would like to see the position after you go up here, here. Yep. So why is this printing 1 and 1? We're not supposed to be at 1, 1. Show me the move forward, please. So, but before that, can you copy the check backward and the move backward to me? I would like to test that on my code before we try to troubleshoot more. I would like to confirm if your code is actually can work on my version of the code or not. So, sorry
Move
again.
forward.
Sorry
Okay,
again.
what do you want me to send you? What do you want me to send you?
Check backward and move backward. Okay, you can put it on the chat, on the WhatsApp, it's okay. Okay, that's good. Let me get that. Okay. I will put them here. So let me start to share, please, and then we look together if we are able to make it work here. If it works here, it means that I think down right is possibly, yeah. And pointer row, why is not defined? I mean, pointer row is already not very sure about why it doesn't accept it, but you did not write global, but and the down right here, it is like that. So let me go to the process input, and then I try to put the command that you did. Where is the process input? No, that should not be here. So process input. Yep. One more time. Here there's the process input. I would say that I would do copy that, and then I would come here. You said PK, and then what did you call here? So we said a print statement back or command PK. I will take that as a start, and then if we say check backward if it is okay, then you actually move backward like that. Okay, let's try to run. So line 301 is an issue. So quite strange. Okay, this is 2, and if the 2 and go, it moves. BK go. Let's have a look. Backward command PK. So I was able to somehow print it, and I was able to go backward. So your code is actually correct, but it seems that the version of the code that you have is corrupted somehow, somewhere. So Euro.
Yeah,
Where are you?
I was here.
Where are you? I lost you. Where?
No, I was muted.
Okay. So, okay. I mean, when I copied your code, the only thing that I needed to change really is that this one. Okay. And also another thing that I needed to change, which is I added this global pointer row and pointer column. And then I do exactly the same like you've done, which is that I wrote this command exactly like you. And it is working. If you look here, backward command BK, and it is executing. It's already moving backward here. So your function is correct, but there is a possibility that you have done some changes to your code, to the other part of the code that prevent this from working. Because, I mean, it could be just you press enter space somewhere that caused this if statement not able to execute. So my first recommendation is that I would give you this whole process input. I will give it to you, and then you copy it to your code. I will put it in the WhatsApp. So I will give it to you, and then please you try to put it in your code, and let's hope that it make things work for you. Let me come here, remove that part. And then turn right and turn left. And this also need to. Okay, what about if you copy that code on your side and see? So copy it. This is a process input code.
Input.
But wait, can you stop first? I would like to ask you before you replace your code, please give me a second. I want you to duplicate this code because we have done many changes in the previous classes. So I would like you to come here before we do anything to the code. That is a bit risky. So, okay, come here. Here. Do you see where I'm writing?
Yeah.
Yeah. Okay. So come here, duplicate this code, please. And I would recommend that you write the date of today. So write main and write today's date. Okay, let's press enter. That's it. Make sure there is no spaces, just, yeah, no spaces at the start. Press enter. Okay, done. So now you can do the change. Okay, good. Try to run. Could not execute it also.
Yeah.
Mm-hmm. I would say I would not waste the time here now. You give me a, can you download this code and send it to me on the WhatsApp? I will go and check it by myself. What could be the possible issue? I will make a comparison between, yes, download. Yep, keep. Yep, keep, yeah, okay. So, and you send it to my WhatsApp and I will do a check for that. What else we can do now?
The right. What do you say this? Let's go back to the main. Hello.
Yes, yes. So what is your question? I
Um,
didn't get you.
I don't know what to do now.
Okay. No, no, we have things to do. So you off your screen and let me share what is our current plan. Okay. You actually send me, you give me the link. Wait, I don't want you to give me the link. Give me the file, please. So give me are you able to send me the file that you downloaded? Yep. Open, show in folder. Show in folder. Yep. And then go to, it doesn't show? Does it show you on the folder? Yeah. Okay. So yeah, that's excellent. Okay, good. Keep it. Yep. Okay. Then we go here. So let me share. I'm sharing. I still need to give you a version of the code that is somehow working. But that I can do on a later step. But let me try to explain this to you, please. So if you can look here, I would like to explain to you the concept of making a circular list. And if we understand that circular list, you will be able to implement having downright. So when I show you left turn 45, this need you to actually make the directions 8 directions instead of 4. Previously, you have only up, right, down, left. So it's only a list of 4 items. If we want to increase that to have maybe up right and down right, and then down left, and I would say up left. So this is, let me see, up, right. This is down, right. This is down, left. This is up, left. So if we look here, the directions now, we added another new 4 directions here, which makes them total 8. So for us to actually modify the turn function to be able to accommodate the new directions, which is now moving by 45 degrees each time. So we need to understand how we implement that. So look at this list. This is a list of characters. And how many characters we have here? We have actually 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements. The current item, or yeah, at the moment we are at A. So now look at this function. So this is the variable that will carry items dot index, and we put the current item. So we are able to use this index function that is part of the commands or the method given to us that we can use with list. So you call it on the variable name for the list, and you pass it an input. You pass it an input so that you know. So if you pass it B, it will return to you the index 1. If you pass it A, it will return to you the index 0. So it will tell you the index of your current item, okay? And then we take the steps from the user, how many steps you would like to move. So like when we forget about the directions now, let me explain here. So if I say that the input, for example, is 3. So if I input here the steps 3, so you will see what is your current position, and then you add 3 to it, and then that will be your new position. So we are at A, and we would like to add 3 to that, 1, 2, 3. So we would like to be at the D. But the problem is, if you are here and you tell me I want to add 3 steps, but you're already at the end of the list, how on earth are you able to actually maintain being on the list when you are already on the last item? So how can you add steps when you are here? So we need a technique that allows us to do that. The technique is to wrap around using the modulus. The modulus allow us to wrap around. So if you are here and you said, I want to move 3 steps, this modulus will allow us to actually start counting from the start of the list. I know that this is a bit tricky. It's not easy at the start, but let us have a look. So I assume that you are at A, and then you enter the steps as 3. So if you say here, the index of A is 0. So I add 0 plus 3. And then I say modulus the length of items. The length of item is 8. So if you try to print on your code, print 3 modulus 8. So what is this going to give to you? I think I lost you. I can guess. Why? Why? What is wrong?
I don't know what that does. I mean, like.
Okay. Relax. Relax. No problem. It's okay. No problem. Can you write this code? I mean, forget about the current code that we are writing. Can you just write this code here? Once you write this code, please share with me yours.
Huh? Should I do what?
I mean, share the code with me once you already write it.
I copied the code already.
Okay, so yeah, you can share with me, please. Okay, excellent, excellent, excellent. And um, do me a favor, just comment that line. Just comment this new index here. Comment that. Okay. So I think nothing will be printed out. Your code's still running, so make sure that.
It's not though.
Go
Not
up,
really.
totally up, yeah. Wow. Okay, go down again. It's supposed to be all commented. Go up slowly. Go down, go down. Wow, it's already commented. Can you stop? Run again. Oops. Refresh. Okay. Try to run. Stop and run. Okay. Name error. Item not defined. So go, yeah. Items with S. Okay, good. Invalid literal. Ah, this is input, not int. Say 3 steps. Press enter. Nothing happened because we already committed that. Okay. So if I tell you I am here and I want to move 2 steps or 3 steps forward. So, okay, can you print items and then you open your bracket and write index plus steps. Okay, run please. What is printed out?
Me.
Okay, where is D? It's here, right? Okay, what is the index of D? Here we 0, 1, 2, 3. So when you put 3, you got D. Can you please run again and enter 4? You got E. So the more you add steps, because I'm adding the steps to the current index. The current index of A is 0. I add 4 to it. It gives me 0 plus 4 give me 4. So the index of the element at the position 4 is what? It's E. That's why it printed E here. Any problem with that?
No.
Is it this is clear? I think this is simple. This is just only indexing the normal array. Is that any difficulty here? Nothing, right?
No.
Okay, perfect. What if you change your current position from A, put it E, please. change here. Yep. Now run, please. And write 3. You want to move 3 steps. Do you see now this hitch? So if I'm at E, I want to move 3 steps. 1, 2, 3. I am going to print H. But what if you write 4 here? Can you run again? Sorry, it will fail?
No.
Okay, let me see. So it is telling me an error, which is index out of range. I want you to explain to me why I am getting this error.
Because there is no 4. You can't move 4 places.
Okay, so it means that I already approached the end of the list and there is no more place I can go, right?
Yeah.
Okay, so what if I want to avoid having this error? I want him, when he tell me move 4 and I already reached the end of the list, I want him to come and print A. How we can do that? Do you have any idea? So the maximum at the moment is 3 steps. I reach here and I cannot move forward outside the list. But I want my list to be circular. It means that if I count here three numbers or 3 steps, and I find that I'm at the end of my list, I need to print A. How can we do that? Okay, I make it easy for you. Come here, please. No. Let me first explain this to you. Just give me a second and then I will allow you to write your code. Just write print. Can you write 8 modulus 8? Okay, and go down and press. No, wait. Come here. Yep. I want you to print 9 modulus 8. And run. And instead of writing 4, write 3 only. Okay, now you are at H because this is allowable. You are at E, you count 3, you are at H, which is okay. Now, what is this? When you say 8 modulus 8, it gives you 0. And when you say 9 modulus 8, it gives you 1. So it means that if my index, if I'm adding the index, the current index, to the step, and it gives me 9, so you are here at 4. This is at position 4. If you add 4 to it, it gives you what? It gives you 8. And if you try to reach the position 8, you will not find it. It's already outside. Okay? But if I use modulus and I say this 8, that is the result from adding index to the step, and I find that there is no place to go, there is no value at 8. Here, it's outside my list. So I want, if I'm outside my list, I want to go back to position 0. So look here. If this is the 8, that is corresponding to the index plus the step, and I make it modulus with 8, which is the maximum number of elements in this array, it will give me 0, which is this. And if I even increase the step and I put 9 here, so it means that the index plus the step is equal 9. So it gives me here 1, which means that you will be at the B. So whatever number you add here, this will make sure that you never face the error that appears that index out of range, because it makes the array circular. So it always maximize or make sure that my output never exceed 8, because I can never say items, which is my list, I can never say 8. I can never say items 9, because the maximum position here is 7. So I cannot say 8. I cannot say 9. I cannot say the position 8. I cannot say the position 9. So I need to make sure that every time I'm trying to exceed the last element, then I go back here. I think you still don't understand me, right?
I get it. So if user inputs 8 or 9, then you ask them to re-input something between 0 to 7.
Yes.
Yeah. So if steps bigger that if index if index if steps equals more, if steps more than
If I understand you correct, you're trying to make sure that the index plus the step does not exceed 7.
Yeah.
Excellent. Okay, that's good. Okay, your code is working. Your code is working. Yes, it's true. But what if instead of the if statement that you put, you uncomment this command and move this command under your print? No, not this. Only this. Only this. Move it under the print. Press enter. Yes. Okay. Now, yeah, that's good. Okay. Can I ask you something, please? Can you use the new index? Make a print statement here. Yes. Make a print statement. No, after the new index. Write items and open square brackets and put the new index. And remove that here, please. Or comment it. Yep. Now run, please. And still put 8. Okay. Do you see what's happening when you put 8? Please enter a number of steps between 0 to 7. And then when you put 8, it give you what? It give you, let me see, the new index is, okay, you are at 4. If you add 4 plus 8, 8 is the steps. It give you the current index. Okay, never mind. Come here. Put a print statement. Print. Put double quotation, index equal, and print the index. So I just want you to print Yeah, the index. The steps I know because I'm already inputting it. Yep. Okay, now run again. You put 8 again. So my index is 4 because E is at location position 4. So if I add 4 plus 8, which is the step, this is the step, it gives me 12. So 12 is outside this, right? Isn't it?
Yeah.
Okay. Now I would like you also to make a comma here and make dash like that, and then put another comma, and then say 12 modulus 8. Run. Put 8 again. So your current index is 4. When you say 12 modulus 8, it gives you 4. So if I count 4, actually, I need to print E again. So E will be, I think I'm losing you. If I keep explaining and actually tell me what do you understand so far?
That
Do you understand what I'm trying to explain? Or you,
yeah,
you
the position of the like the index in the list. If you use modulus,
okay, slowly. Can you try to run and instead of writing 8, put 5? Okay. What we printed here, this print B. My current index is 4. If I add 5 to it, 4 plus 5 give me 9. 9 make B printed out. But we do not know the secret behind that. So if you put here 5, which means that it already exceeds the current array, I did not show an error. I did not print an error. I managed to make sure that if I say this 9 modulus 8, this give me 1. And this one is B is at the position 1. I think this is still difficult, but the key to really implement the 45 turn movement is actually lying here. That we use modulus to make sure that we have a circular array. Whenever you exceed the number of elements, the count of elements here, you actually start counting from the start of the array. This is the secret of using modulus. So without it, you're not able to implement this turn, and you're not able to do anything on the turn function. You will be facing very huge difficulty. So that's why tell me where you're stuck, and maybe I try to find a way to simplify that.
what's this part?
So this part is simply getting the length of items. The length of items is equal 8. So you can even remove this part and put 8. So
Okay.
this part, make sure that the result should never exceed 8, because if you try to write here an index that is bigger than 8, you will actually, so here the last is 7 and the total number of elements is 8. We can never exceed the position 8. If we exceed it or even come to position 8, we will be having error, which is index out of range. So this part, make sure that we never exceed. I mean, even if you say 8 modulus 8, that will give you 0. So you even cannot reach 8. You are not allowed to reach 8 because 8 is outside the list. So if you say 8, I mean, if you look here, 8 modulus 8 give you 0. 9 modulus 8 give you 1. So the more you increase, 10 modulus 8 it give you 2. So I'm always making sure that I never reach this 8 so that I do not have the error of index out of range.
Okay.
And yes, it is okay, but I think you still did not digest it yet. Am I right?
I'm digesting it.
So without that, you will write a lot of if statements, and you will not be able to achieve. I mean, this is just a simple one line that do the job. You to be able to implement that using if statement, you will write a lot of if statements to be able to reach the exact same effect of using the models.
This part, this index part means like the position.
It give you exactly where is the, I mean, it gives you the exact position. So if I say index of E, it will give me 4. So I am printing index here, right? Change this to C. Change this to C and see what is going to be printed out for you here. I would recommend that you make it bigger than 7 so that you are able to get this printed out. Okay, so you see here, the C is at position 2. If you write here D, it will get you 3. So the index is finding the exact position of your element that you put here. You pass it an element, and it will get you where is it in the list. You can do that with integer arrays, with string arrays, with any kind of array values.
Yeah.
Still not digested yet. A bit.
I digested it. Index.
Okay.
The index plus step. Yeah, the modulus, the length. And you print it.
We always need this new index to be between 0 and 7. We cannot afford this to be outside, to be below 0, or to be bigger than 7, so that we don't have an error. We always like to get the index in between these two. This is the limit of my array. If my array become bigger and it have maybe 20 elements, so I need to make sure that I do not exceed 0 to 20. So I always use the length of my array as the base of my modulus. If my array is 8 items, I put modulus 8. If my array is 20 items, I put modulus 20. So At the moment, I would say you stop here, and then let me share with you what we should implement.
Okay.
So I urge you, please, I would like you to investigate more because using modulus supposed to be part of any syllabus that is taught for computer science.
Modulus is the remainder, right?
Yes, exactly, the remainder. And it have a lot of usages. And one of the usages, if you use it with 2, it can tell you if the num here is even, is odd, or even. If you say 10 modulus 2, it will give you 0. If you say 11 modulus 2, it will give you what? It will give you 1. So if you even say 1001 modulus 2, it will still give you 1. So if you make a modulus with 2, it will tell you the number here is even or odd.
Oh wait, modulus only tells you 1 or 0?
Only with modulus 2. Only with modulus 2. So if you make a print statement under your code or even the first line of your code and put 10 modulus 2, so modulus 2 have a specific effect, and also this is taught at the start of any computer programming course. Modulus 2 give you can make you know that this number is odd or even. And if you want to make modulus 3, this will tell you what? This will tell you if the number is divisible by 3 or not. So I'm able to tell how many numbers is divisible by 3 in a certain range by checking the modulus. So if I say 9 modulus 3, it will give me 0. So I will know if it gives me 0 that this is divisible by 3. So if I put here 11, it will never give me 0. So I will know that this 11 is not divisible by 3. Okay, so that is when you say modulus 3. So this is fixed. You should memorize it. Modulus 2 let you know that the number is odd or even. Modulus 3, for example, it let you know that this is divisible by 3 or not. What about modulus 10? Any number that you make modulus 10 to it, it will get you the last digit. So imagine that you have this digit, 1, 2, 3, 4. This is an integer. I would like to say, I would like to get the 4. So I would do what? 1, 2, 3, 4, modulus 10. I would like you to do a print for that. So modulus 10 is to get the last digit from an integer. So that is one of the usages. When you do this kind of modulus, this makes sure with an array, this makes sure that you actually don't ever get index out of range error. So I would like you, please, can you do me a favor and try to print that 1, 2, 3, 4 modulus 10 and see what is the result. Are you still with me?
Yeah.
Did
Not
you?
4.
Sorry again? 4. Okay. Can you change this last to 8 maybe, and tell me what got printed out?
Eight as the last number, as a remainder.
Yeah. Okay. So did you recognize now that? I mean, this is fixed. So you need to memorize that. You need to remember that. Whenever you use modulus 10, you are extracting the last digit of the number here. And if you use modulus 2, it gets you know the odd and even. If you use 3, modulus 3, it gets you to know if this number is divisible by 3 or not. So far, is it acceptable? If not, I would still recommend you go back and check in your syllabus everything you can read about the modulus. But this is a special usages that I'm telling about. And also this is another specific usage that you need to understand by heart, because this is the only way he is implementing the code. He is already using that concept in the code, but he's using it for 4 elements of the array. And then if you stop, please, and allow me to, I think I'm the one who need to stop. I think you can see my code at the moment. Let me know. I would like to share something different. Come here. This is your original code, right? And this is your turn. So can you see here? Can you see this is the original one that without we modifying anything? This is the directions, and we have 0, 1, 2, 3. Okay, he is using what here? Index. So
Yeah.
index, yeah. So based on the index, he will know your current direction is at what position. And then he will add 1 to it, and he say modulus 4. Why he is putting modulus 4 here? Because you have here 1, 2, 3, 4 elements. Your array directions have only 4 elements. So he is using the same concept. This is the original code. If we want to modify this, we really need to understand how this works first before we try to do any modification. So I would say, please study modulus, revise it, and study how this function works so you are able to modify it. And the exercise would be that so I would say this is, yeah, the rotation here. Your exercise is actually to, I think, can you see my screen?
Yeah.
So, I mean, currently the robot is able to turn in 90-degree increments, left or right. But we should extend the robot navigation system or even this player board arrow by adding support for 45 degrees. So you should be having 8 possible directions. At the moment, you are having 3 directions: up, down, right, up, left, right, down. You have those. But we need up left, up right, and down left. So it means that the array that is called directions, you need to think on how to extend it. And to be able to change the current code, which is using modulus 4 at the moment, you need to understand the example that I just gave to you. Okay? So I think.
Can you send me the task? Can you send me the task you said this now? Like this one, like the one before this one.
Yes, definitely. Yeah, definitely. I will do that. Yes. Okay. So please study it so that you're not getting confused. Okay.
Okay.
And then see you next class. My best wishes.
Bye.
Bye-bye. Take care.